flexible.
This is After Deep Blue, or ADB for short. It's a modular robot designed for tactile interactions with people. It writhes, wriggles, twists, and squeezes in response to how it is held and touched. ADB adapts to and reciprocates the energy you put into it through your body. When touched, it comes to life. When stroked, it seeks more contact. And when handled aggressively, it responds in kind. ADB is a platform that allows people to explore the possibility of intimate and emotional relationships with technology through direct physical contact. Over the past decade, social robotics has emerged as a growing trend wherein robots are created to assist and/or provide companionship to people. With few exceptions, these robots have anthropomorphic designs, being endowed with mechanical eyebrows, ears, lips, human voices, and so forth. These symbolic features are coordinated into expressions that mimic the way people appear when emotional. Brows furrow when upset, and lips curl when pleased. The argument for mimesis is that it makes human-robot interaction intuitive. Aesthetically, though, the approach is problematic, as anthropomorphic robots provide cues rather than induce genuine emotion in users. So when a robot frowns, we understand that it is appropriate to cheer it up, but we don't feel responsible. After Deep Blue attempts to work through some of the aesthetic issues by eliminating symbolic features and rooting interaction in touch. The theory is that touch produces sensations of primary consequence because it directly impacts the body. So when ADB squeezes your arm tightly or pinches your hand, this causes genuine discomfort, unlike the frowning robot. ADB is designed to complement the human body as opposed to looking like one. The smooth plastic shells fit comfortably in the palm of a hand, and the robot as a whole can be easily held within a person's arms. It is capable of wrapping around an appendage and exerting different pressures. Its modular design is inspired by approaches to computer graphics, wherein simple representational units, such as pixels or triangles, are amassed together in order to create a high-resolution image. In the case of ADB, the units are robotic touch modules. Each has a limited set of sensitivities and motions it is capable of, but when grouped together, the expressions appear organic and lifelike. The technologies housed within the shells have been selected for their ability to sense and respond to touch. Each module contains a motor, a variety of sensors, rechargeable batteries, and a microcontroller. The sensors detect various qualities of touch, including proximity of skin, pressure of grip, and force exerted by and to the motors. Each module has a standardized joint that it uses to rotate its position relative to its neighbors. Joints are also used to share power and communication. This eliminates any protruding wires from getting tangled on the user's body. It also allows ADB to be quickly extended by snapping on more modules to increase its length. ADB has a decentralized programming scheme to take advantage of the modular hardware design. Each module determines its own movements based on its history or mood, but also is influenced by its neighbors. So, if a module has been treated gently over time, it will be predisposed towards physical contact. If then its neighbor encounters some skin, the module will seek out the person's body as well. As messages ripple between modules, each with its own mood, often the robot will appear to behave with no discernible pattern. But when valences are aligned, suddenly its actions seem to convey a feeling. It nuzzles into a person, or it squirms away. As robots, sensors, and actuators are embedded deeper into the fabric of our physical world, it is important that we consider the forms we are creating and their repercussions. Doing so requires having representations that we can directly encounter. This in a way is the value of ADB, that it gives us a chance to connect with, feel, and assess this technology firsthand.